Question 9, Part C. Consider the function f of x equals log base e of x over x for x greater than 0. Part 1. Show that the graph of y equals f of x has a stationary point at x equals e. We find stationary points by solving the equation f dash of x equals 0, where f dash of x represents the first derivative of the function f of x. Now, f of x is defined as the function or the quotient ln x over x. And since the numerator and the denominator involve the variable x, we need to apply the quotient rule in order to find the first derivative f dash of x. So by the quotient rule, f dash of x is equal to u dash v minus uv dash over v squared, where u is equal to the numerator, ln x, u dash is equal to the derivative of ln x, which is 1 over x, v is equal to the denominator x, and v dash is equal to the derivative of x, which is 1. Hence, f dash of x is equal to u dash v minus uv dash, so that's 1 over x times x minus ln x times 1 over v squared, in this case over x squared. So simplifying the numerator, we get f dash of x is equal to 1 minus ln x over x squared. So as stated before, to find stationary points, we solve the equation f dash of x equals 0. In other words, 1 minus ln x over x squared equals 0. Now x cannot equal 0, so the only way for this fraction to equal 0 is for the numerator to equal 0. In any case, whatever the value of the denominator is, we can't make a fraction equal to 0 unless the numerator itself is equal to 0. So we only need to solve the numerator equals 0. So we need to solve 1 minus ln x equals 0. Rearranging this equation to make ln x a subject, we get ln x is equal to 1. And raising both sides of the equation to base e, so that cancels the ln function here, we get x is equal to e to the power of 1, or just e. Therefore, a stationary point exists where x equals e as required. Part 2. By considering the gradient on either side of x equals e, or otherwise, show that the stationary point is a maximum. Test values of the gradient f dash of x on either side of e. Now e is a value that's approximately 2.718. I'm going to choose two convenient integers on either side of e. In this case, I'm going to choose x equals 2 and x equals 3 and find the value of f dash of x given those values of x that I've chosen. Now when x is equal to 2, the value of f dash of x is approximately 0.077, which represents a positive gradient or a positive slope. Now when x is equal to e, that's our stationary point, so the gradient is 0, so it's a horizontal slope. And when x is equal to 3, the value of f dash of x is approximately negative 0.011, which represents a negative gradient or a negative slope. So if the gradient is positive on the left-hand side of e and negative on the right-hand side of e, the stationary point e is a maximum. So based on the table of gradients, the stationary point at x equals e is a maximum. Part 3. Use the fact that the maximum value of f of x occurs at x equals e to deduce that e to the power of x is greater than or equal to x to the power of e for all x greater than 0. At the maximum stationary point where x equals e, the value of f of x is ln e over e, which simplifies to 1 over e. So 1 over e represents the maximum value of the function ln x over x. Hence, we can form the inequality ln x over x is less than or equal to 1 over e for positive values of x. So we can rearrange this inequality, noting that x is positive. We can take this x here and move it over to the other side by multiplication. So we have ln x is less than or equal to x over e. Next, we can take this denominator e from the right-hand side, move it over to the left-hand side, again by multiplication, and we have e times ln x is less than or equal to x. Now we can use one of our logarithm laws to move this e here inside the logarithm, so we can rewrite the left-hand side of the inequality as ln of x to the power of e less than or equal to x. Finally, we raise both sides of the inequality to base e to cancel the ln function on the left-hand side. So we get x to the power of e less than or equal to e to the power of x. Therefore, e to the power of x is greater than or equal to x to the power of e for positive values of x as required.